The next thing to talk about is the layout of an individual page. So to start with, we're going to have a header zone on the page, which is going to have metadata about this page, information about what's contained on the page. So it's going to say perhaps the number of records on this page, how much free space is on the page, maybe a pointer to the next page in the linked list, and then perhaps some bitmaps or slot tables to find free space on the page, which we'll talk about shortly. So here's some questions that we're going to need to address in the design of our page. Are our records all going to be the same length? That's what's called fixed length pages. Or are they going to vary? Different records will be different lengths. That's called a variable length. So we have to know whether our records are fixed length or variable length, because we're going to design our page layouts differently for fixed and variable length records. Secondly, we need to be able to find records by record ID. How will we do that? Remember, a record ID is a page ID, which gives us this page, and then a location in the page. So what is that location? And how can we make sure that these record IDs are stable over time so that if somebody has a record ID, that ID remains accurate over time? Finally, how do we add and delete records to these pages? So these are all questions we're going to have to resolve in our design. So the options for the page layouts, it's going to depend on the record length, whether it's fixed or variable. And another option we can decide is whether the page is going to be packed or unpacked in terms of its free space. Now in the subsequent imagery, we're going to try to show pictures of pages, but pages are nothing more than a linear array of bytes on the disk, right? Data stored on disk in linear order, 1 byte sort of per position on the disk. Memory addresses are the same, right? So this doesn't look very good on screen, and so we're going to tend to draw these more rectangular shapes where the assumption is we're wrapping around that linear order into a rectangle. So, the bytes of the file, which would go from left to right in linear order, are now going in this sort of zigzag order in this rectangle. Okay, so as you see, rectangular shaped regions of memory or regions of disk pages, assume that they're kind of wrapped in that format. All right, we're ready to look at our first page format. This is for fixed length records in a packed layout. Now, the records are going to be packed densely on the page after a fixed length page header. We need to, for each record ID, calculate the location of that record on the page. Remember that a record ID is page ID, comma, location on page. With fixed length records, it's pretty straightforward. We can just store the record ID as an offset, record number 1, record number 2, and so on. So for instance, to find record number 4, we just use arithmetic. We can say record number 4 starts at the byte offset from the start of the page, which is page header number of bytes plus 3 times the length of a record. And that gives us the offset where record number 4 begins. Similarly, the empty space, the location of empty space on the page can be calculated by looking in the page header, figuring out the number of records on the page, and just calculating the offset of the point right after the last record on the page. So appending records to this format is very easy. We just calculate where the free space is, and we put the record at the end. Deletion's a bit trickier, however. Remember, when we do deletion, we have to repack the page. So deletion's not enough. We also have to repack the page. And what that means is that record IDs that were pointing into this page from elsewhere have to be changed, because what used to be record ID 4 is now record ID 3. Now, if those record IDs that are pointing into the page are stored elsewhere in the database, for instance in other files, it could be expensive to go update them. So that makes this format somewhat less attractive. Here's another alternative representation, which is to do fixed length records with an unpacked layout. And the extra cost here is just to keep a bitmap in the page header that's going to have a bit for each sort of slot on the page. And the record ID now is going to be the page ID and then the slot number in the page. So to do an insert, we're going to find the first empty slot, and we can find out which slots are empty by looking in the bitmap. In this picture, red means a full slot and blue means an empty slot. So for insertion, we just find an empty slot and put the record there and mark the bitmap full. And for deletion, we just clear the bit. So for example, this just cleared record number 3. We deleted record number 3. All we had to do was mark the third bitmap entry blue, and the record essentially isn't there anymore. Note what that means for record number 4. The inbound pointer to it didn't have to change. Because we don't have the packed format, inbound record IDs remain the same. Record 4 is still record 4. There's just empty space for record 3. And no space is wasted on the page with fixed length records in the sense of compacting the page because we can always put a new record in the hole that was left by the previously deleted record. So really the only overhead here is this small bitmap up at the front that keeps track of where are the empty and full spaces on the page. So the unpacked representation for fixed length records is probably a better choice. You pay a very small space overhead for the bitmap, but you get stability of the inbound record IDs. They don't have to change when you do a deletion.